And if you see the diagram, if you see the graph, what they have given, you will get the exact same values. See here, maximum value is 24 volt, and the value of IC is 3 milliampere. So this is going to be your DC. If you join these 2 points, you'll get your DC load line. Actually, this graph is for this problem only. We're able to understand. So first we are finding the 2 endpoints of the DC load line. One is by putting IC equal to 0, you get 24 volt. By putting VC equal to 0, you get 3 milliamperes. So these are the extreme or the maximum values of voltage or current which your transistor can accommodate. So all the operating points will be less than these values only. So AB is going to be your DC load line. And you know Q point will be exactly in the middle, right? So 3 means 3 by 2. 3 by 2 is 1.5 milliamperes. 24 by 2 is going to be 12 volt. So 12 volt and 1.5 milliamperes are the coordinates of your Q point. So 12 and 1.5 milliamperes is the ideal operating point for this BJT. It is the ideal operating point for this BJT. So see the problem here. Finally, after finding the DC load line, you see they are saying for finding operating point, the Q point has to be exactly in the middle. So you can write VCEQ equal to VCC by 2. See, whenever you put Q, it indicates the midpoint or the Q-send point or the operating point of your BJT. And always it is in the midpoint, so it should be the maximum value by 2. The VCEQ will be VCC by 2 and ICEQ will be IC by 2. IC value you got 3 milliamperes, 3 by 2 is 1.5 milliamperes, and VCC you got it as 24, VCE you got it as 24 volt. So maximum voltage by 2 is 24 by 2 is 12 volt. So this is going to be the DC load line. From the DC load line, we are getting the operating point of your transistor. So any queries you have in the part A and part B of the problem, please ask immediately. It is very, very important, and this is the basic problem which we are solving in biasing. So only if you are clear in this problem, you can proceed to the other problems. You can understand and relate them and learn very easily. So any doubt, please ask immediately. Or should I repeat? Please say. If you're silent, nothing is going to work out. Any queries in the problem what we have solved? We have just solved the DC load line, and from DC load line I have explained you how to get the Q point. Any doubt in part A and part B of the problem? Is it clear?
Yes, sir.
Okay. So now after finishing this AC load line, I'll show you how to simulate the same in software, and you will be seeing how the answers are going to be same. Okay. So AC load line, you know one extra thing you have to find, what is called as the AC resistance. And the formula for AC resistance, I told you, it is RC parallel to RL. RC, it is given as 8K in the problem. RL is given as 24K in the problem. Do parallel combination of 8 and 24K. So it is 8 into 24 by 8 plus 24. So you get RAC as 6 kilo ohms. Now, using the two conditions for formulas for VCE and IC, use the formula VCE equal to VCEQ plus ICQ into RAC. See, this VCEQ and ICQ values will come from the DC load line. VCEQ is 12 volt, ICQ is 1.5 milliamperes, RAC we got as 6 kilo ohm. So you get the VCE value is 21 volt. This is for the AC load line exclusively. See how the values are changing for AC and DC load line. For AC load line, it is 21 volt. For DC load line, you are getting it as, we got the answer for DC load line as 24 volt, correct? So see the values will not be same for AC and DC load line. Same way, IC equal to ICQ plus VCEQ by RAC. So ICQ, it is 1.5 milliamperes from DC load line. VCEQ is 12 volt divided by RAC. RAC is 6 kilo ohm, what we have derived. So we got the answer as 3.5 milliamp.